Let's talk a little bit more about graphing quadratic equations. We've talked in previous videos about how to graph an equation of the form ax squared, and that just takes your parabola and multiplies it by a factor that causes a vertical stretch or a vertical compression. So it'll make it kind of taller and skinnier, or maybe shorter and fatter. Maybe it'll even flip your parabola over. So today we're going to take that and we're going to build onto it by adding a constant at the end. So we'll start by graphing this one. To graph, I'm going to just create a table and we'll explore what that -4 does to our graph. Again, I will just put in 0 and then a couple numbers below, a couple numbers above, and then I will plug each of these x's in to find the y value that goes with them. Remember to do your exponents first, and I will repeat this going down the table. So there's my table. Let me clear all my work and I will create a coordinate plane so we can sketch these. I plot each of my points starting with -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0, and connect it with that smooth U-shaped curve, giving me this parabola. We did briefly touch on your vertex last time. So here my vertex is at the point 0, -4, and then my axis of symmetry drops straight down the middle through that vertex, and that's the equation x equals 0. So here is your parabola. You'll notice that the last few that we did started at the origin. So they looked more like this, but this one was moved down 4. And that comes from the -4 that we have at the end of our equation. So the x squared is the parabola, and then that -4 afterwards says take your parabola and then drop it down 4 units. And that's how we got to our purple graph. Let's do one more. Here I do have a coefficient of -3, and that's going to change our graph again. Let's make a table, plug in our x's to get our y's. So there's my table. Again, let me clear all my work and I will sketch our coordinate plane to create the graph. And there is my parabola. My vertex here is at the top, and that is the point 0, 6, and my axis of symmetry goes right down the middle of my graph. That's the equation x equals 0. Couple things to notice about this graph. First off, it faces down. Well, it faces down because our leading coefficient, that 3, is negative. So negative is going to flip your graph vertically. We call that a vertical reflection. Then it definitely did get much thinner than the graph I had in the last example. The last one looked like this. Granted, my coordinate plane is a little wonky, but it is much thinner. So it kind of got tugged on the ends to make the graph thinner. Then the last thing is that it got pushed up 6. So my vertex is up here at 6, and that comes from the +6 added onto the end of the graph. So we flipped the parabola, we stretched the parabola, and then we just pushed the whole thing up 6 to create the graph that we have here. All right, let's do one more, and that is this one. When I make my table, I'm going to this time be a little bit more conscious about the numbers that I plug in because I'm going to be taking 1/3 of everything. So I could pick -1, -2, and the numbers I did before, but I don't want to deal with fractions, so I'm going to pick numbers that will divide by 3. So I'll pick maybe -3, -6, and then 3 and 6. Our numbers might end up a little bit bigger than normal, but that's okay. We're not picking as small of x values, so that's to be expected, but they should still fit on our graph. So now that I've made my table, let me clear all the work and we will sketch the graph. So I start with 6, 11, that's all the way at the top here, 3, 2, 0, -1, -3, 2, and -6, 11. So my graph definitely looks different than the last few, but remember that we plugged in some larger numbers so that we wouldn't have to deal with those fractions. So we kind of zoomed out and we have a little bit of a different perspective. My vertex here is at the bottom at 0, -1, and then my axis of symmetry goes right down the middle again through my vertex at x equals 0. So in this one, our leading coefficient, this 1/3 here, is positive. So our graph still faces up. We didn't have any vertical reflections. The 1/3 does cause our graph to kind of squish down and become a little bit wider and fatter. And then the -1 takes your whole parabola and drops it down 1 unit. So that is why we're sitting down here at -1. And that's it. So thanks for watching, and I'll see you next time. Bye.